Assalamualaikum and salam sejahtera to all my students. Okay, for maths lesson today, alright, we are going to continue the subtopic from the chapter 11, isometric transformation. So I would like to discuss about the subtopic 11.6, rotational symmetry. Yeah. So this one you can see in your math textbook, page 234. Okay, so subtopic 11.6.1, rotational symmetry. It is a shape has rotational symmetry if the shape does not change after rotation, even though it has less than one rotation. Okay, so this one, please look at this diagram here. We have a diagram, triangle ABC and also the triangle CAB. Yeah. Okay, so the triangle ABC, all right, after go rotation, so become the triangle CAB. All right, so this one example of the rotational symmetry. And also what you also need to know for your information, the recycle symbol, all right, this symbol, I, I think most of you already see the symbol for the recycle, okay, is example of the rotational symmetry symbol. Rotational symmetry. Symmetry is an exact match in terms of size and shape of one part or the side of a direction or object. For rotational symmetry, when the shape or image is rotated less than 360 degrees at a fixed point, the shape will look the same. Okay. Okay, now look at this one. Okay, example 27. Okay, question asks you to identify the object which has rotational symmetry. Okay, the first one, A, yes or no. So as you can see, this one, this one, the answer is no. Okay, and for B there, this one, yes. Okay, that means this object, if we do rotation, the image after rotation will have the same position, same size, same shape with the object after the rotation. So this one is the rotational symmetry. So the answer is yes. And for C there, the answer is no. Okay, so the next one, subtopic 11.6.2, order of rotational symmetry of an object. The number of image that can be generated in the same rotational center and become the original object is called the order of rotational symmetry. The order of rotational symmetry is equal to the number of axes of symmetry of an object. Okay, the order of rotational symmetry is the number of time a shape moves to return to its original shape in a complete rotation. The number of axes of symmetry is equal to the number of order of rotational symmetry. Okay, all right. Okay, now look at this one. One example here. Example 28. Determine the order of rotational symmetry when the position of A changes to position D in the diagram on the right. So this diagram, so we have one polygon here. So this one point A, point B, point C, point D, point E. This one is a regular polygon. So question asks you to determine the order of rotational symmetry when the position of A changes to position of D. So how to do this one? All right, you have to use a tracing paper. Draw and determine the rotation order A to D, from point A to point D. So look at this one. Okay, the first rotation from A to B, you rotate A to B. So that is the first order. Now for B to C, from point B to point C, the second order. And the next one, from point C to point D, it is a third order. So the answer is, it is a third order or after going 3 rotation. Okay, so this one the answer. So the order is 3, or means it need to do 3 time rotation from point A to change to the point D. Yeah. So like this one. Okay. Okay, so the next one, all right. So look at this one. Self practice 11.6. Okay, we will discuss a few questions here for this self practice 11.6. Okay, now look at this one. Self practice 11.6. Question number 3. The symmetrical object is rotated at a point. State the order of rotational symmetry if 1. Position A is at position C. So position A at point change to the position C. So how many order? So how to do this one? So look at this one, from A to B, one order. From B to C, second order. So the answer is second order. Or you can write like this one, second order. First one, A to B, first order. B to C, the second order. So the answer for 3-1 is a second order. Okay, for 3-2, position B is at position D. B at position D. So how to do this one? So B to C, first order. Then C to D is second order. All right. So the answer is also same, the second order. Okay. The last one, question 3. Position C is at position B. Position C at position B. So how many order? All right. So C to D, first order. D to E, the second order. E to F, third order. F to A, fourth order. And A to B, fifth order. And B to C is sixth order. So the answer is the order of 6 or sixth order. Question 3. Okay, so that's the answer for this one, self practice 11.6, question 3. Okay, all right. Now look at the. Okay, now look at this one, generating excellent exercise. Okay. Okay, so look at question number 1 here. Okay, the diagram on the right shows a polygon A mapped to the polygon A prime under a reflection. Identify the point, the mesh. Okay, A, the image of point P, and B, the object of point G. Okay, so remember this one. A means object and A prime means image. So how to find the answer for question 1A? Okay, the image of a point P. So look at this one. P is here. So after go the reflection, the image for point P is F. Okay, this one. So the answer is F. Point F. And number 1B, the object of point G. So point G is image here. So the object here is what? So this one. All right. This one, the point U. So number 1B, the answer is point U. Okay, all right. Okay, so all right. So I want you to do some exercise for this for our lesson today. Okay, so I want you to do exercise this one, generating excellent. Okay, please answer question. Okay, wait, I want to find what is the question. Okay, I want you to answer question. Okay, question 9. Okay, please do question 9, question 10. Yeah, so two questions. I want you to try to answer this one. Question 9 and question 10. Yeah. Okay, so please do in your math exercise too. So if you have any question about this exercise or the lesson today, you can ask me in the Telegram. So that's all for our class today. All right. So thank you, class.